Welcome to the day 6 session of APM with Python. Today we are going to talk about the concepts of errors and exceptions, and tomorrow we will be taking about the concepts of object-oriented programming. So let us start with our today's discussion. So the first thing we are going to talk about is the different types of errors which we may encounter while we are writing down a program. So error is effectively something which has been caused by us as programmers, which impacts the execution of the program and jeopardizes the expected output. So there are different types of errors which we may encounter. So we have got syntax errors. Then we have got runtime errors, and we have got these logical errors. Okay, so these are the different types of errors which we may encounter: syntax, runtime, and the logical errors. Syntax errors are those errors which happen at the time of compilation, or they are detected at the time of compilation, and these errors are basically when we forget, for example, you have forgotten to declare a variable, or you have forgotten to clearly provide the indentation, etc., etc., or you have used a command wrong, like you have misspelled the command. So compilation errors are basically errors done at the syntactical level at the program, and they are detected at the time of compilation. So basically the program will not execute. It will throw you an error and it will tell you it cannot execute it. For example, I am asking the user to, let's say, enter a number. So I say num is equal to int input, enter a number. And then I say now prnt num. Is prnt a command? It is no command. Print is a command, prnt is not a command. So I have misspelled it. So I get this error undefined variable prnt. So when you try to execute this program, it will basically execute one line, and in the next line it will basically tell you that there exists an error, prnt is not defined. Since this program is interpreted, Python as a scripting language is an interpreted language, that's why even the execution got started. But it threw an error at this line. Okay. This line did not have any error, so it got executed. This line had an error, so it threw a error that it does not understand what is PRNT. So this is effectively an example of a syntax error. Then let's have a look at an example of a runtime error. A runtime error is an error where the program though looks fine, but an error is thrown at the time of execution. So at the time of execution, we may encounter a value which we are not able to interpret or gauge. This can cause the program to misbehave. For example, if you are trying to divide a number by 0, or you are trying to access an array position or a list position which does not exist. Okay, so these are all could be the runtimes error which are basically created at the time of execution. Let's say this is the list we have created and I want to say let me comment out this. Do you get this index error, list index out of range? You don't see any error in here, do you? There is no error displayed in here. The editor is not able to detect any error, okay? Because there is no syntax error, but there is a runtime error because at the time of execution we are trying to access an index position which is 3. There is no index 3 here, right? The last index value is 2. 0, 1, 2. So we are trying to access an position which basically is going to throw an index error. Okay. So this is the error which we encounter at the time of execution. It's called a runtime error. Make sense? And then we have got logical errors. Logical errors are those errors which basically come up when there is a mistake at the pseudocode or at the logic of the program. So whether it's a mistake at the pseudocode or the logic of the program, this error is generated. Okay, these are called as logical errors. For example, you have used a comparison symbol incorrectly, or you are trying to solve a problem but you created a bad logic. So you will never get an expected output. You will always get a bad output. For example, I say A is 10 and B is 20, and then I say if A is less than B, print A is greater. Now in here for this particular program, if A is less than B, I want to print A is greater. Does it make sense? Is it right? Logically, is it right? It's wrong, right? If A is less than B, I should have printed B is greater, not A is greater. Do you all understand? If A is less than B, A is smaller or B is greater. So no matter whatever I do, this program will always provide us with a bad output because the usage, the logical usage of this comparison operator or the interpretation of the usage of this comparison operator is wrong. Okay. So this kind of error is known as logical error, where we have created or we have conducted a mistake while trying to solve the problem at hand, and it will always give us a bad output until unless we correct the pseudocode or the logic of the program. So broadly classifying the types of errors which we may encounter as programmers while working on a programming, working with the programming language for a program, are broadly classified into these three error categories: syntax error, runtime error, and logical errors. Any questions in here? Anything which is not clear? So as you guys are trying the assignment solutions at your own time, have you encountered any types of error while writing down a program of these three categories which we have created? Did you encounter any type of error while writing down the program? All three? Okay, great. Yeah, so the most common error is syntax error, which is generally seen in programming languages where syntax is pretty difficult. For example, like Java. Python still has English-like syntax, so chances that we make those mistakes are less, but nevertheless we do. And then you can have definitely logical and the runtimes error. So now when you encounter an error, try to categorize to understand what type of error you have been faced with. The next concept we are going to talk about is the concept of exceptions. Exceptions are effectively situations which arise during the execution of the program which causes the program to misbehave or act abruptly. So exceptions are basically an event which occurs during the execution of the program and it disrupts the normal program's instruction. Okay. So it's an event which occurs during the execution of the program, and it disrupts the normal behavior of the program. For example, let us say you are trying to talk to a database, but somebody by mistake switched off the system where the database servers were hosted. So your client, which you have created to talk to the database, will start misbehaving and will throw an exception at you. Let's say you are trying to access a file, but somebody deleted the file from that location. Again, your program will misbehave. Or let us say you have created an list, but you are trying to access a value which doesn't exist. Again, your program will misbehave. So these are the events which occur during the execution of the program, which disrupts the normal behavior of the program. And as programmers, we should be able to handle exceptions by writing code which is prone to exception in a try except block, so that the program doesn't behave abruptly. So if the program is trying to behave abruptly, we should be at a we should have a stronger hold at the program, we should have an upper hand, and we should be able to control that misbehavior instead of allowing the program to go haywire. Okay, the reason we would like to do that is we do not want the system to get unstable because of the program's misbehavior. We do not want data loss. We do not want data to be corrupted and all that things which can go wrong if your system starts misbehaving because your program threw an exception. Okay, so we do not want all of these things to haunt us later. That's why it's important that whenever we are writing the code, we should be able to perform or do exception handling. Since we will be learning APM, which is an example of automation, let me give you a scenario of automation in here. Let's say you have got 100 test cases to execute, out of which 5 test cases required a file. At the time of execution, from the 21st test case to 25th test case, those were the 5 test cases which required the file for their execution. If you have not taken care of exception handling scenarios in your test cases which require an external entity usage, what would happen? Let us say you do not have done any exception handling for test scenarios which required external file handling, and you forgot to copy the file at the respective location. How many test cases will execute for a nightly run out of 100? So only 20 will execute, right? Because from 21st onward it will throw an exception. Because of the exception is thrown, the control is taken away from the execution and it is given to the operating system. Now operating system doesn't know what to do with it. So it will basically display the exception and exit the execution. So in the morning when you come, only because these 5 test cases were not created well, you got impacted in time for execution of around 75 test cases. 20 got executed, 5 were anyways never going to get executed, so 75 test cases which could have also been executed did not execute. This is not an acceptable situation, is it? You will not like it as a tester where there is time constraint and you have got these testing cycles created. But if these 5 test cases had exception handling taken care into, then 95 would have got executed. Now this is still extremely acceptable because first of all your program will not behave. Your automation suite execution will not get disrupted because of some unforeseen event, and you will be able to execute 95% of the scenarios. Only 5% of the scenarios are not going to get executed, and they will do a clean exit. They will throw a clean error. They will not hamper the execution totally, but with their only themselves. Okay, so do you understand the advantage of exception handling and why is it necessary? So this is one of the examples to be provided. Now, how do you inculcate exception handling? So basically the syntax is you say try, then you start with your colon indentation. You have a code written in here which could be prone to exception. Then you have an except block where you catch any exceptions. There could be more than one type of exception which could be thrown. So you can have multiple except blocks. And then if there is no exception, you can have an else block which tells us there is no exception found. So try, except, and else. That's the syntax. So try, code prone to exception, except, handle the caught exception, else, in case exception doesn't come. You also have another entity called as finally, which will always execute whether exception comes or not. So if the exception comes, else will not get executed. If exception doesn't come, else will get executed. But finally will always get executed whether exception comes or not. Is the syntax clear? What about pop-ups? Do you write exceptions for that? No. Pop-ups are generally handled with the help of something called as alert. You will see that later. So we have got try, except, else, and finally. So in try, we basically have code which is prone to exception. Except, we basically, when we have caught the exception, what we want to do with it. Else, in case the exception itself has not come. And finally, we'll execute whether exception comes or not. So this is how we write down our try, except, else, and finally block. Let us see a program. Here we have created A as 10, B as 10. We start with our try block. We say print A by B. In case this division causes an error, exception, we go to the except and we say print error. Otherwise, we say print no error, and in the finally we have said will always execute. Right now we get the output as 1. We get the else block executed no error, and the finally executed will always execute. Let us make B as 0. This time, do you see error? So it did not execute this statement, it did not execute this statement. When it was trying to execute this statement, the exception came, so it went into the except block and executed this. Else will no longer be accessed, but finally will definitely get accessed. So it's a simple code. Try on your system and observe the same behavior as I have observed. Do it, please. Okay. Now let us see another type of error or exception which we will be working with, handling. So in here we are going to work with a file, but the file is not available on the respective position. So what will happen if that is the situation? So we say inside the try, we are trying to open a file in which we are trying to write. If in case the file is not available, we are going to say except exception. Then we are going to say print errors can't find the file or read the data. Else we will say the content of the file is successfully printed and we are going to close the file. Then we have got some code which is outside the try except block. When you run this program, since there is no file at the respective position, all these things will not get executed except the statement. Right? And since we were smart enough to handle the exception is handled. So that is why this code gets executed. If in case you would have written a code like this where you haven't taken care of exception handling and you had a code like this, then when this line threw an exception, none of the lines of code after that will get executed. So that is the benefit of the try except else block which we have seen in here right now, which because it is handled, we were able to execute the rest of the code. Is this clear? Now we are going to talk about exception as an argument to be used. So when an exception is generated, it's an entity in itself, it's an object in itself, and you can access that object to fetch different values associated with it. So we will see that in here. We have got a method created, def temp convert, we provide var in here. Inside the method we have our try except block where we simply say return the int version of the var. That's what we do. We say return the int version of the var. If not, if it causes an exception, then we say except exception as e and we say the argument does not contain number and we print e.args. So if you have a look at this object e, you will be able to access the different attributes associated with this object e. E.args being one of them, which basically displays the error message. And print type e will basically tell you what type of exception class does this exception belongs to. So this is the error message. Invalid literal for int with base 10. The type of exception class is value error. So exceptions in Python all belong to different classes. So you have got value error, you have got division by zero error. So these are all the built-in classes. These are the things we can access with the exception object. arithmetic error, buffer error, lookup error, assertion error, attribute error, EOF error, import error, index error, and the type of error which we have seen, value error. These are all basically the built-in exception classes which we may encounter while working with the exception. So the type of exception we encountered was a value error, when it receives an argument that has right type but inappropriate value. So though you were trying to convert a string into a number, the string XYZ cannot be converted into an int, right? Because it has got a bad value associated with it. So you get a value error created. If this would have been 10, we would still have been able to work with it, right? But since it was XYZ, we were not able to work with it. So it had a bad value. Okay, and it tells us what is the value, what is the exception class. Is this clear? So we'll take a small question right now. Write down a program where we create a list of 5 numbers. Write a step to access a value in the list giving a wrong index. Print the exception by using e.args and the type of exception encountered. So simple program. Please do it right now and share your code. Attempt it, please. So what was the type of the error which you encountered? What did it print? What was the built-in exception class name? Index error, right. Good. Fine, Marian. Another 5 minutes. Attempt it, please. You will definitely not get the mail on Hotmail or Yahoo ID. Only Gmail IDs get access. Don't you get the mail in spam also? Have you checked your spam folder? Go to your mail settings and ensure that the email ID using which I'm sending you mails is not filtered out or blocked. Most of the times these files have attachment and the attachment is code. So Gmail may filter it out. So put it in the safe IDs. You have to do that setting in your email address. Marian, why are you taking so much time? It's a very simple program. And anyways, the template which you will be using to write down the code is shared. Are you struggling with some concept? If you are going to use the for loop statement, you will not encounter an out of range index value until unless you deliberately do it. You just have to try to print a value where in the list where the index is not available. If you are going to say for I in num list, it will always print that. Yeah, this is better. So did you get the type of error? You would have received that the type of error is index error. So the built-in class associated with the type of error which we will encounter in this program is index error. Okay, that is what we had to observe in here. Any questions, anyone, about the concepts we have discussed so far? That's okay. Anyone has any questions? You have any questions? So we are going to talk about the next concept called as raising an exception. Sometimes when we are writing down the code, we can ourselves can cause our code to throw an exception. For example, we want a particular situation to be handled as an exception situation in that code. For that, there is a keyword available called as raise, which causes an exception to be raised. Okay, so let us take an example. Here we have created a method called as level f, which takes as argument something called as a level. We say if the level provided is less than 1, we want to raise an exception invalid level. Else we want to print a level. Then inside the try except block, we simply call this program with the method with the level which is less than 1. This will cause this exception to be generated, which will be caught by us. So do you see this invalid level -1 getting printed, which is the message provided by here? And the built-in exception class was exception only. So this is an exception which has been raised by us, which has been called by us. So if we encounter a situation in a program which we want to treat it as an exception, we can do so by using this keyword raise. Any questions in here? Read this program. What is the purpose of the raise keyword I have just explained? What did I say about the raise keyword? Yes, we are forcing to raise an exception. We are trying to trigger the exception. Very good. So in here, in this method, we have simply written that if the level is less than 1, we want to trigger an exception. We want to cause an exception to be generated. And then in the program below, where we are trying to work with this method, when the exception will come, we will be able to handle it. Let us say here the level is 10. Now the exception will not come, right? Exception will come only if we are encountering a value which is less than 1. So let us say we encounter a value 0. Then we are trying to raise an exception. We are trying to force an exception. So what we are trying to do, we are trying to force an exception. Do you all understand this now? Please ask. It's a journal exception. For example, if you want to change the type of exception being generated, you can provide the exception class. For example, if I say this is an index error and I run this program, I will get that the type of this exception is an index error. Okay? Since I provided an exception, I will get the type of the class associated with this is exception. So is this clear, Samir? What is the significance of it? The significance of it is while working on writing down a program, if you are trying to work on conditions, generally how would you write down your if statement? Let us say you are trying to work on a program where you say that ask user to enter two numbers, print the greatest. Simple program. Here, when you are trying to work on this program, is it mandatory that since you have asked for two numbers, the person is going to enter number? Can you predict that they will not enter alphabet? They can enter alphabet, right? So, can you write down a better program where in case an alphabet is encountered, with the help of this value error, you basically prompt the user saying back that what you have entered is a value error. Please enter an integer. So these exception classes help you capture something which can cause an issue and you would like to foresee and raise that issue and handle it with the help of exception. I can also handle it with the help of if statements, which I have done anyways, and use some print statements to do with it. But we have a separate class in itself called as exception classes, which we can extrapolate or which we can use to handle these uneventful or unforeseen situations and write down better code. So raise an exception is effectively an advantage for us, that we ourselves can make the program throw an exception if it is encountering an input which is not in an acceptable state. So instead of waiting the program to throw an exception, we ourselves are calling the exception to be raised. We have more control with the help of this keyword. Okay? Try this out and we will take a break now. So we'll take a break of 10 minutes and the session will resume at 8:41. So you guys can try out this program on your systems. We are going to take a break now and the session will resume in next 10 minutes. Resuming the session, so far what all we have seen is, we have seen about the concepts of exception, errors. We have seen how can we work with the exception object which gets generated, and we have also seen that how we can ourselves raise an exception. Now, so far we have been working with the built-in exception classes in Python. What if we want to create our own exception classes? This concept is a little complicated. It becomes complicated because it is involving the concepts of object-oriented programming, which we have not yet discussed. So we are going to talk about this concept tomorrow, once we are done with discussing the concept of object-oriented programming, so that we understand how we can work with our own user-defined exceptions. Okay. So we are now going to start about the concept of OOPS. We are going to talk about a little bit theory today and see an implementation of a class and objects created with it, and rest we are going to cover up tomorrow. Before I start this topic, any one of you aware about the concept of OOPS? Okay, so both of you are aware, which is great. So let us discuss a few things, and then we will see how we can create a class and objects in OOPS in here. So the concept of OOPS basically tell us that everything around us is an object. Okay, so everything around us is an object. When we say everything around us is an object, what does it mean? It means that things around us have got attributes, which is basically the which is basically the properties associated with it, and they have got functions, which are basically the methods associated with it. So things around us have got attributes or properties and functions or method around us. So let us take an example. Let us say a phone is an object. Okay. What are all the properties you can think about a phone? So you have the OS, you may have model, you may have screen size, you may have whether it is a touch button or a normal keypad phone, etc. etc. These could be the properties. What could be the functions? Make call, receive call, switch on, switch off, browse net, camera. These could be the functions associated with the phone object. Now what is a class? A class is a blueprint or a template from which objects are derived. So a class is a blueprint or a template from which objects are derived. So effectively these properties and functions are declared within a class. Okay. You define all these things within the class from which the objects are derived. Objects are also known as an instance of a class. So what is an object? Object is also known as an instance of a class. So at that particular moment, the snapshot of the class which gets created is an object. Objects of the same class are similar. Objects of different class are not similar to each other. So another object phone would be similar to the first object phone, but an object phone will not be similar to an object car, let's say. Is this clear? Can you guys tell me what is a constructor? Not really. What is not clear, Marian? Which part is not clear? I think you told me you already know oops. I did not say anything outside the context. What part and object is not clear? Okay, what aspect you don't understand? You understand what a class is? Okay. So object is an instance of a class. It is an derivative of a class. So basically, the properties and the functions which get associated with the object are defined within the class. And the classes which are the objects which belong to the same class are similar. For example, I, you, Samir, we all belong to this class called as human. But if somebody is outside the earth and is coming from Mars, then they will not be belonging to the class human. They will be different than us. Our functions and properties are similar, but we are not similar to that of a car or a mobile phone or a computer or a house, which are all objects of different classes. So the concept of OOPS basically says that everything around us is an object, which effectively means that everything around us has got a set of properties and functions which differentiates it from another thing. So a constructor is effectively a default method which gets associated with the class, generally having the same name. In Python, it is not that. In Python, it is known as the init method. Okay. In Python, the constructor doesn't have the same name as that of a class. It is called the init method, which is always called when we create an object of the class. So whenever we are trying to create an object of the class, we get called this init method. Okay. This init method is called when we create an object of the class. The idea is that it basically provides a default value or it initializes the different properties associated with that of the class to provide it to the object instance. So we are going to right now create a small class with an init method and see its usage. So the class we are going to create is called as the employee class. It has got a variable called as emp count. This is the variable at the class level. Remember, it is not an object variable, it is a variable at a class level. Then we have this constructor or the initialization method, the init method, which takes something called as a self. Self is similar to, if you have come across the keyword this, it is similar to that. It basically refers to itself. Self refers to itself and two attributes name and salary. We say self.name is equivalent to name, self.salary is equivalent to salary. So basically when we create an instance of this class, while creating the instance of the class, we will have to provide two attributes name and salary. This name and salary will get associated with the object of that class. And we increment this class variable by 1. Whenever init method is called, an object gets created. So we instantiate this employee count by 1. This is a class variable. This is a variable which is created at the class level. The init method is the initialization method which is going to get called when we are trying to create an instance of the class, which effectively means when we are trying to create an object of the class. When we are going to try to create an object of the class, we will be passing two data points, name and salary, which will get associated with the object definition. And we are going to increment the employee count by 1. It's the syntax, Samir. That's how you write it. This is basically the way we write the init method. It's the syntax. It is not a method which is defined by the user. It is an internal method associated with all the Python classes. So that's how it has to be displayed. And then you have got a function created called as display employee, which basically prints the information associated with the object, name and salary. So we have created two employees. So we say emp1 is equal to employee. We provide two arguments while creating the object, name and salary. Employee 2, name and salary. So when line number 10 is encountered, it will basically go to this init method and will provide the name and the salary for the object and will increment the employee count. Similarly for line number 11. Dot is the accessibility operator which allows us to access the properties and the function associated with the object. So you can see these three properties and these functions which are available for us to access. So we call the function display employee. Okay. And then we simply print the total employee count. What would be the total employee count printed? 2. Because this method is going to be, or this statement is going to be called twice for the two objects which gets created. So when you run this program, this is the output which we get. The display employee method printed the name and salary and the total employees are 2. Is it clear? I will be sharing this code for you guys to try it on your own, and then I will be giving you a program to also write. So have a look at it. If there is any question, let me know please. So any questions? Try that, Samir. You will get an error. You cannot do that because it does not know what EMP count is otherwise. So EMP count is a variable. A class variable will not be accessible in the constructor without the class reference. What is accessible in a constructor are basically object variables, that too with the instance of self. To access the class variable inside the constructor, we have to provide the class reference because this variable at the class level, not the object level. The method constructor works at the object level. This also works at the object level. Any other question? EMP1 and EMP2 are objects, Marian. They are not at the class level. These are the objects or instances of the employee class. So this is the question you guys have to try right now. You have to create a class called a student which has got three properties: name, age and percentage. Then you would have to create three objects of the student class. You have to create a method to display the information which prints the name and the percentage of the student. So this is your, and you have to print the name of the oldest student. So go ahead and attempt this problem, please. Are you guys trying? Okay, okay, fine. So you guys can complete this and either mail it to me or we will have a look at it tomorrow. Okay. So the idea is you are able to understand that how do we create a class, how do we create an object, how do we initialize them, and how we can work with the, yeah, you will get error, Samir, and how we can work with the different attributes. For example, if you just have to access the name of this employee, you can simply say print emp1 dot name. So I've shown you this to help you understand that for the program you guys are trying to write, you can simply access the age of the each student by referring to the object along with the accessibility operator followed by the name of the attribute you are trying to access. So it is not complicated. Just try to accept it, just try to use it properly. Okay? So try to solve it. Don't make the concept more complicated than it is. So work on this program and show it to me in the class tomorrow. So we have learned about the concept of object-oriented programming at the theoretical level. We have understood how we can create a class, how we can define properties and functions, how we can create object of the class. We have discussed about the concept of object variable and class variable, and we have taken a question to be done. Tomorrow when we meet, we are going to talk about the concept of inheritance, the concept of overloading, overriding, and we are going to have a look at something called as interfaces, and then we will have a look at the user defined exception classes. So that all we will learn tomorrow. The concept of object oriented programming is one of the most important concept for any programming languages. Okay, we will learn eventually, like next week when we have a look at some modules in Python, we will learn that APM itself is also a package or a module in Python, and we are going to use the concepts of OOPS to work with the tool like APM or Selenium, etc. Okay, so we'll learn all of that. Okay, then, thank you so much for today. I'll see you guys tomorrow. Take care. Bye, everyone.